we have to find the given limit. So we know the identity that cosine of theta times secant of theta equals to 1. Therefore, secant of theta equals to 1 over cosine of theta. So we're going to use this identity and limit as theta approaches to 0 of secant of theta minus 1 over theta equals to limit as theta approaches 0. And we substitute secant of theta with 1 over cosine of theta and minus 1 and over theta. So that's equals to limit as theta approaches 0. And here we're going to make common denominators. That's going to be 1 minus cosine of theta over cosine of theta and over theta. So that's equals to limit theta approaches 0 of 1 minus cosine of theta and over theta times cosine of theta. So now we know the identity that 1 minus 2 sine squared of x equals to cosine of 2x. Therefore, 1 minus cosine of 2x equals to 2 sine squared of x. That means that 1 minus cosine of theta equals to 2 sine squared of theta over 2. Now we're going to use that, so we get the limit as theta approaches 0 of 1 minus cosine of theta over theta times cosine of theta equals to limit as theta approaches 0 of, we substitute 1 minus cosine of theta with 2 sine squared of theta over 2. And in the denominator we have theta times cosine of theta. Now we're gonna multiply and divide our limit by theta over 2 squared. So we get limit as theta approaches 0 of 2 sine squared of theta over 2 over theta times cosine of theta. So we multiply by theta over 2 squared and divide by theta over 2 squared. Now we get limit as theta approaches 0 of 2 over theta times cosine of theta, then times theta squared over 4 and times sine squared of theta over 2 over sine squared of theta over 2 over theta over 2 squared. Then we get limit as theta approaches 0. Then we can cancel theta and this approach 0, close to 1. So that's going to be 2 over cosine of theta times theta over 4 and times 1. Now we substitute theta with 0 to get 2 over cosine of 0 times 0 over 4. So that's going to be just 0.